So a microscope is an optical instrument that is used to magnify, to produce images of objects that have an angular size bigger than the angular size that the object would have if you just took the little thing that you want to look at and you put it at 25 centimeters. Right? That's what you're looking for. So how do you do that? So I have set up here a microscope, believe it or not. And so for a microscope you have two lenses. The one that is closer to the object is called the objective. The second one is called the eyepiece. And here we have an object. I wonder if you can see that. Let me get this. An object right here, right? That's where the tip of the arrow that we're talking about would be. The light rays come out of that, the tip of the arrow. They hit the objective. They will be focused at some point over there. So that's where the image is. Right here is the image. Right here is the object. Let me put an arrow there. Here is the object. And here's an image of the object right there. Formed by the objective, right? Now what's particular about this setup of the eyepiece is that, if I could get some smoke to go there, notice the light rays coming the way they exit the eyepiece. They're exiting pretty parallel, right? So they're doing that because the image formed by the first lens is being formed close to the focal length of this lens. It's close to the focal point, so anything that you put close to the focal point of a lens, of a converging lens, the light rays will diverge. They won't diverge. They will look parallel. They come out parallel. Right? So if you're looking at this situation, if you're using those two lenses to look at an object, if this is supposed to magnify, then you will have to compare the angle, the angular size of the object as it appears for the observer located here, right? So that angular size of that object is, I take these parallel light rays, they seem to be coming from that direction, right? Seem to be coming from that direction. And that's the angle theta. Okay, the bottom of the arrow is focused here, and the tip of the arrow is focused over there. Okay, so that is the angular size of the object, of the image, this image that is being formed. That is the angular size that the microscope is giving me. The question is that bigger than the angular size of the object if I were to just use my eyes and look at the object at 25 centimeters and see that's the top, that's the bottom, that's a certain angle defined there, right? Is the previous angle that I just measured bigger or smaller than this one? That's the question you want to ask yourself. Is this angle bigger or smaller than the other one? For this very rudimentary setup here on the board, you can see that this angle is bigger than that one, not a lot bigger, but it's a little bit bigger. I think yesterday I got it to be about 2 times that. So that means that the magnification of this microscope that I set up on the board will be 2. If this angle was 2 times bigger than the angle at 25 centimeters. Right? So what is the magnification of the microscope then, in general? Well, you need a distance here, L, the distance between the two lenses. So this is the eyepiece. This is the objective. The object is going to be placed somewhere here. So where is the image of the object formed by the objective? Well, if you're close to the focal point of the objective, which is right here, F of the objective, if you're really close to that focal point, the image is going to be far away from this little lens, right? But far away compared to the focal length. That means if the focal length is 2 millimeters, far away will be 2 centimeters. That will be already pretty far away, right? So what you want to do, as I said before, is you will want to adjust this distance between the microscope and the object, which is over here, so that the image of this object is going to be formed at the focal point of this lens. So this is the focal point of the eyepiece, and that's where you want your image to be. So these light rays will be coming from the object, of course. And this is the focal point of the objective. So let's label this object here. This is F of the objective. So this distance, as we said, we want that to be the focal length of this lens. And if that is true, then the light rays turn parallel. And for the person looking at this, they seem to be coming from this direction. And that is the angle theta that we talked about. So let's call this distance h prime. The height of the image here is called h prime. And this has a distance height h. The angle theta, you can tell from here that it's going to be just as before. It will be h prime divided by the focal length, because I'm placing this right at the focal point. So this is the focal length of the eyepiece. That is your angle theta. Opposite is the tangent, right? And for small angles, opposite divided by the adjacent. This is the focal length, h prime. Now what's h prime in terms of h? The size of the object, the actual size of the object. I'm going to assume that the distance at which this was formed is very close to being L, the length of the microscope. Typically in a microscope you're talking about focal lengths of millimeters in size, and the length of a microscope would, typically is 160 millimeters. So there is definitely, it applies that L is much bigger than F. So this distance will be, the distance to the image, right, would be L minus the focal length of the eyepiece, but that's pretty close to L. Okay, so I'm just going to say that this distance is L. The magnification of the first lens will be the distance to the image, which is approximately L, divided by the distance to the object. The distance to the object, we say that we're going to have to put that pretty close to the focal length, to the focal point of the objective, to get the image formed far away, right? So this is equal to h prime over h. So h prime is how many times bigger than h? M times bigger than h, right? H prime is m times bigger than h. So I put that there, m times bigger than h, divided by the f of the eyepiece. And we know that m is going to be close to L over f of the objective. This is your m. And we multiply by h and we divide by f of the eyepiece. That's how big the image of that object is going to look when you're using a microscope. But is that bigger than, is this doing better than just holding the object at 25 centimeters? That's the question that you always want to ask. So does it magnify? That's what it means to magnify. So we need to compare that. How many times bigger is theta with respect to what you would get just by looking at the object? Right? So we figure out our theta here. How much is the angle there, the angular size of the object. So we just divide it. We have L over f of the objective times f of the eyepiece times h, and this is divided by the near point angular size of an object is the size of the object, h, divided by the distance at which you place it, which is 25 centimeters. H is cancelled, and you have your final expression for the magnification of the microscope. Looking at that over there, up there, and the 25 comes on top. 25 centimeters. The L is on top, and I'm going to put here the f of the eyepiece and the f of the objective. Right, that's what you get. Now this magnification is a product of two quantities. One having to do with the focusing power of the eyepiece, the other quantity having to do with the focusing power of the objective. So what people do is that they call this quantity the magnification of the eyepiece, and this quantity is the magnification of the objective. This is the quantity that tells you how much bigger is that intermediate image, right? How much bigger than the actual object. This is the quantity that tells you how much you can think of it as the magnification of the eyepiece, right? How much bigger does the eyepiece make the object, that image form at the focal point? How many times bigger is it when you use the magnifying power of the eyepiece? So this is what's quoted when you look at the information of a microscope. Those are the numbers that they're telling you. This is an integer, has no units. This is an integer, has no units. Right? So what they do is they write an x next to it. So the m's are specified that way. The m of the eyepiece, for example, might be 10, and the m of the objective might be 50, which tells you that the overall magnification of the microscope is 10 times 50. So that would be 500 times. So an object, when you look at an object using a microscope that has this particular focal length for the eyepiece and focal length for the objective, then it will look 500 times bigger than it will look if you just looked at it with your naked eye. That's what that number means. Okay?